Hi, we are Team Adams and our company name is Co-Develop. Our team made a vehicle tracking system for a car dealership. In the process of building the software, we exercised efficient software engineering practices. These practices helped us get past what could have been big challenges. Since there are 6 of us, we had 1 team leader, 3 coders, and 2 testers. There was not a budget for this, so we used free resources such as GitHub, PyCharm, and Visual Studio. And we followed a 15-workday plan. We listed 8 requirements for this project. Make sure to have a user interface, have the ability to search, add, delete, and edit vehicles and their attributes, and make sure every vehicle belongs to only one locational data structure at a time. The system must have the ability to process customer orders and make car sales. And finally, all vehicles must have a history log. We used object-oriented decomposition. We created 3 classes for implementing the software. They were car, customer, and purchase. Each have a series of attributes and functions, and each was equipped with a constructor. Here is our system design. The legend in the top right corner shows that the orange arrows designate data flow, and black arrows designate writing capability. At the top left corner, you see the user in gold communicates to the GUI, which satisfies requirement 1. The GUI communicates to the main function, which communicates to the 3 classes in green. The car class communicates with the functions that read, add, edit, and delete cars. This satisfies the 2nd, 3rd, 4th, and 8th requirements. Our data structures are listed across the bottom in orange for car, customer, and purchase objects. It is within these data structures we satisfy requirements 5, 6, and 7.
Shown is the pseudocode for our vehicle tracking system. When the program starts, the selection menu will be shown to the user and the list for the inventories will be initialized. The user will input an integer selection between 1 and 8 to choose from the options menu. The first option prints out the current inventory or prints out that there is no inventory available. The next possible selection allows the user to search for cars by either make and model, by car type, or by engine type. By car type, that refers to whether the car is a sedan or an SUV, and by engine type, that is whether the car has a gasoline or diesel or electric engine. The user will also be able to add and delete cars from the inventory as shown from selection 3 and 4. Selection 5 allows the user to process customer orders for cars that are on back order, on order, or were recently delivered. Selection 6 allows the user to view the information of sold vehicles as well as the information of customers who purchased the vehicle. Selection 7 allows the user to update the delivery date, future maintenance date, and unscheduled repairs for the purchased vehicle. The final selection, 8, allows the user to exit the program. A graphical user interface was also implemented for the user to make selections from the menu.
So for this project, we chose to use Python as our language, and we use Python for numerous reasons. First of which is high readability. Due to the syntax of the Python language being similar to the English grammar, it made it easier to document the code and maintain the code. So when we passed the code between group members, it was easier for them to get a sense of what was happening due to how easy it is to read the Python language. Another thing is that it's suitable for a test-driven development. So while you are developing your code, you are constantly testing, and it made it easier because the Python is a compile time language, so it made it easier to make your changes and modify. And on top of that, automated testing is easier to implement as well. In addition, Python has lots of libraries to aid development, and we used one of those libraries in order to create a GUI. Now, when we were programming, we programmed with modular code in mind. The reason we did modular code is because it was easier to track down the source of the problem whenever you are separating your code into little pieces. Also, it helps improve the elegance of the code, and it helps improve the logic, which goes into the second reason of an object-oriented approach. We separated our code into like car objects, purchase objects, and customer objects. That way it was understandable how the data was organized.
Unit testing verified the core functionality of the system, such as searching for a call or a purchase. In order to cover a variety of paths through the code, multiple items were tested for each test case, each with their own inputs and expected outputs. Testing was automated for back-end code and manual for front-end code, such as code controlling the GUI interface. Automatic testing was carried out using unit test mock library in order to simulate user input. Program output was captured using a string IO object. A test item consists of calling the function with the given inputs and using one or more assert statements to verify that the outputs match the expected values. A test case was made up of one or more test items, testing the same operation. Common errors uncovered with this testing were inefficient checks for objects of type none or mishandling of class member variables. Manual testing followed the same basic framework of testing each operation with different inputs to show all cases covered. Coverages of the code by automated testing was collected using Python's coverage library. By running the code using the coverage run command and specifying source file on which to collect coverage data, a coverage report was generated that could be viewed via the coverage report command.
So I handled the integration testing for our project. I was able to split it up into 4 main categories for integration that had similarities. The first one was integration of our inventory functions. I found that this consisted of the print inventory function, the search inventory function, add card inventory function, and delete card from inventory function. And I tested these by first adding a card to the inventory, and then printing that inventory to make sure the card was successfully added. I then searched that inventory to make sure the search function worked properly, and then I would then delete the card from the inventory, and then reprint the inventory to make sure that the card was actually deleted. The next group that was similar is our order integration. And for this consists of our view cars on order function, add cars on order, view cars on back order, add cars on back order, and view cars recently delivered and add cars recently delivered. For this, I added a car to each of the 3 sections, being order, back order, and recently delivered. And then after each of those, I went on to view cars in each of those 3 sections. Our third group is sale integration. And with this, I found that the functions that communicate with each other are what we use to add a sale, delete a sale, modify a sale, and view sale information. I tested this by first adding a sale, and then I would view it using the view sales info function. And then after that, I would modify it, and then use the view sales info again to make sure the modification worked as intended. And then I would delete the sale, and then view the sale info yet again to make sure the deletion occurred as intended. Our fourth and final integration group I called the sold history integration. This one was very simple. It only consisted of 2 separate functions. One that is modify a sold car's history and view a sold car's history. And to test this, I would first modify a car's history, and then I would view it to make sure that modification took place as expected. And then I also was in control of system testing. For this, I basically just made sure everything worked together as intended. It was basically really similar to integration testing, just on a bigger scope of things. You want the project as a whole to work well and mesh together. And to do this, I took a large list of random vehicles that I had found on the internet and used that as our inputs to test the system as a whole. And in doing this, I got the expected outputs thrown through, and the list allowed me to know what I was expecting the entire time. Before the GUI was implemented, we also had a few scripts that we used for testing, and this allowed us to streamline the process and make it possible to run multiple tests with the same inputs and expected outputs. And this was helpful because we were able to test things a lot quicker, not having to create a list of inputs and figuring out what those expected outputs would be each time we wanted to run a test. We were unable to break our program with any stress tests that we ran, and we did that by trying to overload the volume on certain functions, and with any reasonable input we were unable to break it using any sort of stress testing. Also, testing after the GUI was implemented, all of the timing was uniform and almost instantaneous as expected, and there did not seem to be much of a change regardless of the size that we were using.
Hello, so I'll be talking about system delivery and maintenance. So the installation of the system. To install this system, you must have the latest version of Python installed on the user PC. As well, Tinker, which is a Python software, must also be installed for the GUI to run properly. Then we'll be moving on to maintenance. For corrective maintenance, we will be able to provide corrective maintenance by fixing any bug issues that come in from the customer after they receive the product. This could range from fixing simple design errors to more advanced issues, such as adding or deleting from inventory just not working. Adaptive maintenance. We will be able to provide any adaptive maintenance in the case that there were any changes to the GUI software Tinker. So in the case that they release an update, we will be checking beforehand if the update works properly with our software to make sure no errors occur. For perfective maintenance, we will be able to provide this by implementing any changes that the customer will want, such as in the case if the customer will want to add more filtering options, or they will want to expand the classes that make up the vehicles, or just UI changes. For preventive maintenance, we will be able to provide this by constantly brainstorming ideas that might break our program or destroy our stored data, and try to prevent issues like that from occurring. Hello, so I'll be demonstrating how our VTS software works. So right now, we designed this and coded this in Python. The GUI comes from Python software called Tinker that generates all the windows, the entries, and the buttons. So what we're going to do is go through each option and show how it affects our inventory list. So it starts off by first asking the user to please make one of these following selections: print inventory, search for calls, add calls to inventory, delete call from inventory, process customer orders, manage call sales, and update call history, and then finally exit. So we'll start at 1. We'll first print out the inventory. So I already had it put in. So 1. So as you can see, it opens another window of our inventory list. Right now we have several calls in our list. And as you can see, it's showing all these calls. To get back to the main menu, you just have to click the main menu option. Alright. So now we will search for calls. So when you search for calls, you have 3 following options that can occur. You can search for calls by the make and model, the call type such as a sedan, SUV, sportsback, and etc., or the engine type if it's gas, electric, or diesel. So I'll go through all of them and show how it works. So first, we'll search by the make and model. Opens up an additional window and asks to please enter the make and model of the call. So let's say we want to search for an Audi e-tron that was in the list. So we put that in, you search for that, and then click submit. And boom, all the calls will show up. So let's search for another call. Let's say, believe a Nissan Sentra was in it. Click submit, and one appeared. So let's search for a call that's not in the list. So let's say Nissan Altima. So you click submit. Oh, there are no calls in the inventory matching the make and model. So at that point, it will come back. It opens a message box stating that no call with that make and model occurs, and then it'll go back to the screen. So then you can go back to search main menu, which just destroys that window, so you don't have all these additional windows open. So let's search for call type. Nope. Click this same button. So 2, submit. So it opens up an additional window. Please enter the type of call. So we'll do sedan, submit, and then boom, Nissan Sentra. You can do that with SUV, etc., as long as it's in the list. So we'll go back to the main menu. 3, engine type. So in this case, let's search for an electric call. Click submit, and it pops up in a list of the other calls that were in the list with electric engine types. At the moment, we just have a bunch of the Audi e-trons in the list that are electric. If we do gasoline, it should pop up the Nissan. Oh, there's actually no call with that. I believe it's just gas, and it pops up the Nissan Sentra. Search for main menu, go back to main menu, and you're back here. So this time, let's add a call. So when you add in a call, it opens up an additional window that shows all the requirements that you have to input for it to add a call. So we can first, we can just put in any random call. Let's do another Nissan Sentra, Nissan Altima. Call type, gas, engine type sedan, handling, does sharp turns, instrumentation, it's just good. Say the 5 stars. Exterior, let's put black interior, audio, booming, comfort, 4 stars. Maintenance does not require any. Warranty, 50,000 miles, and then nothing for extra. And then click submit, and then it goes to call added, and it takes you back to the main menu. So then if you open up the print inventory and you scroll all the way in the bottom, you see that it was added to our list with a new ID. Alright, so let's say we want to delete that 1859. You would go to for delete calls from inventory. So it pops up an additional screen, and then it says, please enter the ID of the call to be deleted. So let's say there's a call ID that we haven't done. What would occur? Let's say 500 is not in the list. We want to delete it. A pop-up message will occur that says call is not in the inventory. And then it destroys the window and takes you back to the main menu. And then let's say that we do have a call that we want destroyed, like 1819. Not an inventory. Let me go back to see if I had the right number. 1859. So we go back. 1859, submit, and it deletes the call from the inventory. So we print the inventory, we scroll down, and boom, not in the list anymore. So go main menu. So process customer order. So how this works is that you have 7 options. You can view calls on order, add calls to the order list, view calls on back order, add them to the back order, view calls recently delivered, and add calls recently delivered, or head back to the menu. So what I would do is add a call on order and then view it, since we're starting fresh on the order. So let's add one in. It works the same as adding a call. So Nissan Sentra, sedan, gas, then 5-star, boom, instrumentation, plenty of sensors, safety, 5 stars, black, booming, 4 stars, maintenance, none, warranty 50,000, miles, extra, Bluetooth. Then submit, adding call to order. So then we would have to go back to that screen and then view the calls on order. And it opens up an inventory list of all the calls on order, and at the moment we only have one in, and it's the one we just added in. Previous. And then viewing calls on back order works the same, and recently delivered works the same as well. So let's head back to recently delivered. Alright, so we want to manage call cells now. To manage call cells, you first have to add the cell, and then you can delete it, modify, view the information, or return to the main menu. So let's first add a cell. Please enter an ID. So I know one of the calls we had on had an ID of 33. So we submit, we add the buyer's name. So I'll add myself. So Marcus, Prez, put a phone number 123 5555. Address, USF, sold it for 23,000 on today's date, 04/22/2021, and it's supposed to be delivered within 7 days. So let's say it's delivered on the 29th. Date for maintenance for the first maintenance check. Let's say 08/29/2021. Repairs needed. Regular maintenance. Submit. And call cells added. So then let's modify it. Let's first view it. You would have to input the call ID which was 33, and then it has all the information that I inputted in. So I go to previous. Let's modify it now. How modifying works on here is that it's split into two categories: customer data and purchase data. So let's do customer data first. So let me change, I actually got a new phone number. So let's change the phone number. So ask, please enter new phone number. So it's 896-523-444. Submit, phone change. So then it goes back, and then let's change something on the purchase data. So sold amount, sold data, delivery date. Let's say a storm occurred in my neighborhood, road was blocked, can't get it delivered, so it has to be delivered the following week, or the 1st of May. So let's change the delivery date to 05/01/2021. Submit. Delivery date change. Then we'll go back. Go back, and we'll on this. So let's see if it was actually changed. The phone number and the delivery date. So put in 33. And then as you can see, the delivery date was changed there. Previous. So let's delete it. The cell. Let's say I actually canceled my order. So we do that. Input 33. Deleted call with ID 33. So now if I try to search for that cell information, we put 33. There's no cell for a call with the ID 33 because I deleted it. Go previous. Let's return to main menu. So how update call history works, it actually works with the call cell. So since I deleted it and there was nothing in call sold, there'd be nothing in history. So I would have to add another one real quick for the update call history to show. So 33, put my information again. USF 15,000 0501 2021 0508 2021 then 0908 2021 just maintenance. Submit. Call added. Return to main menu. So let's update call history. So how this works is that you can modify the sold call history or view the sold call history. Or return to main menu. So to modify a sold call history, you would have to click the option 1, put in the ID of the sold call, and you can do modify maintenance date or repairs. So let's say we need to modify repairs. Something occurred, new repair, flat tire. Submit, repair note change. So previous. So now we would view the sold call history. We would have to put in the ID again. And then as you can see right here, it's delivery date, maintenance on, and the repair needed of the flat tire. Then we go to previous, return to main menu. And then we will be able to exit out of the program. So when you select 8, it brings up a confirmation page that says, are you sure that you want to quit? Yes or no. If you click yes, program ends. What did that? It ends.